Now we are going to start our exercise 2.2, question number 1. Write the base and exponent in each of the following. 7 power 15. Here base is 7 and exponent is 15. Part 2, minus 189, exponent 10. So base is minus 189 and exponent is 10. Part 3, 108, exponent 64. Here base is 108 and exponent is 64. Exercise 2.2, question number 2. Indicate which of the following are positive real numbers, which are negative real numbers. Okay, let us recall. A negative base raised to an even exponent. Base is negative and the exponent is even. Then the answer is always positive. A negative base raised to an odd exponent. Base negative, exponent is odd. Then the answer is always negative. The first one, 8 exponent 4. Here we can see that the base is positive. If base is positive, then no need to check the exponent. When base is positive, then answer is always positive. So first one is positive. Second one, base is negative. When we have a negative base, we have to check the exponent. Here exponent is an odd number. So the answer will be a negative integer. Third one, negative base, even exponent. Negative base, even exponent. Answer is always positive. So part 3 is positive. Question number 3. Which is the correct way of finding the value 38 bracket 83 exponent 9? Two options are given to us. We first multiply 38 with 83 and then find the ninth power of the product. Second option, we first find the ninth power of 83 and then multiply it with 38. Here second part is the correct option because to solve it we will follow the BODMAS rule. According to BODMAS rule, we have to solve bracket first. So we have to solve this bracket first. We will find the ninth power of 83 first and then multiply it with 33. 38. It means part B is the correct answer. Exercise 2.2, question number 4. Simplify the following. We have to simplify by using the laws we have learned. Minus 91 exponent 4. Here we can see that we have a negative base with even exponent. Negative base, even exponent, answer will be positive. So no need to write minus 91 multiply minus 91 multiply minus 91 multiply minus 91. Instead, you can write just 91 multiply 91 multiply 91 multiply 91. Multiply them, you will get the answer. That's it. Part 5. 5 exponent 4 multiply 5 exponent 2. Here you will use the law of exponent. Bases are same, exponents will be added. So 5 exponent 4 plus 2, 5 exponent 6, and you will multiply it 6 times to get the answer. 5 multiply 5 multiply 5 multiply 5 multiply 5 and then multiply 5. You will get the answer. 6 part exactly same as part 5. Bases are same, so powers will be added. 4 plus 3 plus 8. A exponent 15, that's your answer. Part 7. Here you can see that we have different bases. Base A will be written with each other, then base B will be written with each other, and then base C. Now we will apply the law of exponent. Bases are same, powers will be added. Here exponent is 1, exponent is 5. So A exponent 5 plus 1, B exponent 2 plus 3, C exponent 2 plus 3. So answer is A exponent 6 multiply B exponent 5 multiply C exponent 5. Part 8. You have to use the law of exponent. Here you will use the law. Bases are in multiplication and we have a whole exponent over it. So this whole exponent will be applied with the bases. So it will be 8 exponent 4 multiply 3 exponent 4. Now we can solve 8 exponent 4 and 3 exponent and then multiply both of them. Okay, or we can solve it like 8 exponent 4 means 8 will be multiplied 4 times and 3 will be multiplied 4 times. We will multiply all of them and we will get the answer. Part 8 is done. Part 9. Minus 4 multiply minus 5. Here we can apply the rule. If we have a whole exponent, the exponent will be written with all the bases. So minus 4 exponent 3 multiply minus 5 exponent 3. Here we can see that the bases are negative and the exponents are odd. It means there will be a minus sign with our answer. So minus 4 exponent 3 will be solved as minus 4 multiply minus 4 multiply minus 4 and minus 5 multiply minus 5 multiply minus 5. We will multiply all these 4's. We will get 64 and minus minus plus and then plus minus is minus. This is minus 64. In the same way we will multiply these minus 5. Now we will multiply minus 64 with minus 125. Minus minus are plus and 64 multiplied by 125 is 8000. You may use calculator to check the answers. Part 10. The same rule will be applied here. Bases are multiplying with each other. We have a whole exponent over them. So this exponent 13 is applied on A and B both. You have to do it yourself. Part 11. Exactly same. Do it yourself. Part 12. Again same. Okay. We have 3 multiply 5 multiply x multiply y and we have a whole exponent 14. This whole exponent 14 will be applied on every base. 3 exponent 14, 5 exponent 14, x exponent 14, y exponent 14. Solve it and you will get the answer. Next we have exercise 2.3. Simplify. Part 1. 10 exponent 3 whole exponent 2. Again we have to use the laws of exponent. We can see that here we can see that we have exponent over an exponent. Okay, when we have exponent over an exponent, then the exponents are multiplied with each other. So 10 exponent 3 multiplied by 2, that is equals to 6. 10 exponent 6 and the answer is this. Second part, 2 exponent 3 exponent 2. Again we can see that we have exponent over exponent. Again applying the same rule and solve it yourself. Part 3, same rule will be applied here. Exponent over exponent over exponent. So all these exponents will be multiplied. So base 3 with exponent 2 multiply 3 multiply 2, that will be the answer. Part 5, sorry, part 4, minus 2 exponent 2 exponent 2. Again exponent over exponent, then it means exponents will be multiplied with each other. Minus 2 exponent 4. Exponent is even, there will be no negative sign with the answer. Okay, and answer is 16. Part 5, bases same and the numbers are dividing with each other. So 3 exponent 7 divide 3 exponent 2, bases are same. So we will write the base once and then subtract the exponent. So 3 exponent 7 minus 2, answer is 3 exponent 5. You may use calculator to find 3 exponent 5 or you may consider it as your answer. Minus 4 exponent 4, minus 4 exponent 2. Solve it in this exact same way as solved part 5. Okay, bases are same, we will subtract the exponent. So minus 4 exponent 4 minus 2, which is equal to 2 minus 4 exponent 2. Solve it and you will get the answer. Okay, this part 7, a exponent 9 upon a exponent 2. Again the same law will be used here. Part 8, same law. 4 and 8 will be reduced. 4 ones are 4 and 4 twos are 8. A exponent 3, A exponent 1. Exponents will be subtracted. B exponent 5, B exponent 5. Exponent will be subtracted. Okay, this will be the answer. Part 9 exact same way as we have done part 8. Same goes with part 10, part 11, part 12, 13. Okay, all these questions will be solved in the same way as we have solved part 8. Numbers will be cancelled out and the exponents with same bases will be subtracted. You have to do these questions yourself. Next we have exercise 2.4. Question is again simplify. We have to solve our question and give a simplified answer. 3 upon 12 exponent 6. We have two options here. First, we can reduce it or we can apply the rule. Exponent will be written with both numerator and denominator. We have both the options. So it's better to reduce it first. 3 upon 12 will become 1 upon 4 and whole exponent 6. This whole exponent 6 is applied now. 1 exponent 6 upon 4 exponents. The law is used here. No? The law which says A upon B whole exponent 6. So A6 upon B6. It means AX1 exponent 6, 4 exponent 6. Solve it and you will get the answer, or you can write it as your answer. Minus 12 upon 5 exponent 5. Again, if the bracket can be simplified, you will simplify it first. Here we cannot simplify it. We cannot reduce 12 and 5. So it will remain same and the law of exponent will be applied here. According to law, minus 12 exponent 5 and 5 exponent 5. Use calculator to find the values. You will get the answer. Part 6, again the same law. You have to do it yourself. Part 4. Okay, here you can see that we have negative exponent here. So it's better to convert it into a positive exponent by reciprocating it. L upon m will become m upon L and the exponent will become 3. Okay, this is the first option. Second option is we apply the exponent first. It means L exponent minus 3, m exponent minus 3 and then reciprocal it. So it will be m cube upon L cube. We have both the option. We can change this negative exponent into positive exponent first and then apply the rule, or we can apply the rule first and then convert it into positive exponent. Both are the correct options. Part 5, exact same as part 4. Apply the exponent first or reciprocal it to change negative exponent into positive exponent. Both are the correct options. Okay, here we have applied the exponent first. 8 exponent minus 2, a square exponent minus 2, b exponent minus 2, 3 exponent minus 2, c exponent minus 2 and d exponent minus 2. Now reciprocal it to convert negative power into positive power. Solve the exponents. 3 square will be 9. 3 square will be 9, yes. This will be c square, this will be d square. 8 square will be 64. A square whole square will be a exponent 4 and b square. We cannot reduce it further, so this will be our answer. In the exact same way, you will solve part 6. Part 7, you have to do it yourself. Part 8, exact same. Part 9, exactly same. Here you can reduce this 6 and 18 first before applying the exponent. It will become simplified. Part 10, again you can cancel out this minus and minus first. Also this 5 and 30, 5 ones are 5, 5 6 are 30. You can reduce it first. Similarly, you can solve this x exponent 10 and x exponent 3 first by subtracting the exponent. Same will happen with this y, and then apply the whole power. It will be easier. Okay, minus 5 and minus 3 will be reduced, and answer is 6. Here we can see x exponent 10, x exponent 3, it will be x exponent 10 minus 3. Y exponent 8, y exponent 2, it will be y exponent 8 minus 2. Simplify it, 6 x exponent 7, y exponent 6 whole power 2. Now we will apply this whole exponent. Okay, 6 exponent 2, x exponent 7 whole exponent square, y exponent 6 whole exponent 2. Here we can see that we have exponents over exponents, so the exponents will be multiplied. 6 square is 36, x exponent 14, y exponent 12. This is the final answer. Same happens with part 3, part 11, and then part 12. Part 12 exactly same as part 10. You will reduce 6 and 12 first. M exponent 4 and m exponent 2 will be solved together. N exponent 3, n exponent 2 will be solved together, and p exponent 2 upon p, this will be solved together, and then you will apply the whole exponent. Next we have radicals and square root. Properties of a square root. Square root of a is equals x. When we find the square root of any number, we will get x as answer. It means if we take the square of x, we will get a. For example, if we find a square root of 4, the answer is 2. If we take square of 2, we will get 4. This is the property. Okay, if we take a square root of a number, we will get an answer. If we take the square of that answer, we will get the number whose square root we have found. This is the first property. Second property says square root of a multiplied by square root of a is equals a. Take an example. A square root a multiplies square root a means we have square root a multiplied by square root a means square root a is a square. This square and this square root will be cancelled out, and we will get a. This is how we get this property. Okay. Next we have square root a multiplies square root b is equals square root a b. If two radicals are multiplying with each other with different radicand, so we will write both of them in one single radical sign. Square root a upon square root a is equals 1. Square root a and square root a both will be cancelled out, and we will get 1. This is how we get this property. Part 5 is a upon square root a is equals to square root a. This is the property. Square root a upon square root a upon a is equals 1 upon square root a. This is the sixth property. Square root a upon square root b is equals to square root a upon b. Here we can see that we have different radicands. The number written inside the radical sign are different, so we will write them in one single radical sign. Part 7 and part 3. Okay, when the radicands are different. Here we can see radicals are same. When they are multiplying, we will get just the radicand, and when they are dividing with each other, we will get just 1. One more thing, this property holds for multiplication and division only. We cannot write it as square root a plus square root b. It is not equals to square root a plus b. Okay, this property holds for only multiplication and division. It does not hold for addition or subtraction. Okay, when they are multiplying with each other, we can write them in a one single radical sign. When they are dividing with each other, we can also write them in one single radical sign, but not with multiplication and division. Eighth property, a square root b plus c square root b. Here we can see the radicands are same, square root b, square root c. So we will simply add this a and c, and the radicand will be written as it is. Now using these properties, we will solve exercise 2.5. Again the question is simplified. Part 1 is 169. We will find the factors of 169. Factors of 169 will be prime factors of 169 will be 13 multiplied by 13. Or we can write it as 13 square. A square and a square root will be cancelled out and we will get just single 13. Square root of 180. Again finding the prime factors of 180. To find the prime factors, we will do this process. 180. Okay, 2 nines are 18, 0. 2 45s are 90. Then 3 15s are 1, and then 3 5s are 15, and then 5 ones are 5. Okay, in this way we will find the prime factors. So prime factors of 180 are 2 multiply 2 multiply 3 multiply 3 multiply 5. Here we can see that we have two 2's, so it will be 2 square, it will be 3 square, and it will be just 5. 2 square, it means its square and square root will be cancelled out. 3 square means its square and square root will be cancelled out. This 5 will be written in the square root. So we will have 2 multiply 3 multiply square root 5. 2 multiply 3 is 6, and the answer is 6 square root 5. Part 3. Square root 12 multiply square root 12. It will be just 12 according to the property we have learned before. Square root 16 multiply square root 12. Here we can see that the number written inside the square roots are different, so we can write them in one single square root. So 16 multiplied by 12 in one square root. We will find the factors of 16, we will find the factors of 12. Factors of 16 will be 4 multiplied by 4, or we can take them as 2 multiply 2 multiply 2 multiply 2. Factors of 12 will be 2 multiply 2 multiply 3. Again we will make the pairs 4 square, 2 square, and 3. Square and square root will be cancelled out. This 4 will be taken outside the radical sign, this 2 will be taken outside the radical sign, and 3 will remain inside the radical sign. So 4 2s are 8, 8 square root 3. This is the answer. Part 5, exactly same as part 4, you have to do it yourself. Part 6, square root 15 upon square root 5. Here we can see that there are different numbers in the radical sign. So we can find the factors of both of them, or we can write them in one single radical sign according to the property. Both are the correct options. So factors of 15 will be 3 multiplied by 5. We can write it as square root 3 multiply square root 5. This is square root 5 and this is square root 5 will be cancelled out, and we will left with only square root 3, which is the answer. Part 7, you have to do it yourself. Part 8, according to the property, you can directly apply the property here, or you can solve it completely. To solve it completely, we will find the factors of 18, which is 2 multiply 3 multiply 3. Again, factors of 18 will be 2 multiply 3 multiply 3. Numerator will written as it is. In denominator, this 3 will be taken outside the radical sign because it will become 3 square, and square and radical sign will be cancelled out. So this will be 3 square root 2. This 3 will be cancelled out with the 3 in the numerator, and we will left with 6 upon square root 2. This 3 and this 3 will be cancelled out, and 2 multiplied by 3 becomes 6 in the numerator and square root 2 in the denominator. Now to remove this square root 2 from denominator, we will multiply numerator and denominator both with square root 2. We will multiply it with square root 2. Numerator will be written as it is, and the denominator will become square root 2 multiplied square root 2 will be just 2 according to the property. This 2 and this 6 will be reduced, and we will have 3 square root 2 as the answer. Part 9, you have to do it yourself. Make the factors of 28, and then square root 7 will be cancelled out, and you will get remaining as the answer. Part 10, 3 root 5 plus 8 root 5. Here we can see square root 5 are same. So we will only add this 3 with this 8. So 3 plus 8 will be 11, and square root 5 is written as it is. Part 11 in the same way as part 10. We have to subtract square root 8, square root 8. Both the radicals are same. So 5 minus 2 will be 3. 3 square root 8. This is the answer. In the same way, we will do part 12. Now the nth root of a positive real number. We have learned the properties of square root. Now we are learning nth root. It means any root. Okay, it may be cube root, it may be fourth root, any root of a positive real number. The properties that are followed by any root of a positive real number. Okay, the first thing, this symbol is called the radical sign. The exponent written here is called the index, and the thing which is written inside the radical sign is called the radicand. Previous exercise we have learned it for square root only. Square root means the exponent here is 2, which we do not write. Okay, we are now learning the properties of nth root. The thing which is written inside the radical sign is called the radicand. This is called the radical sign, and the number written is called the index of the radical. Now the properties. Properties are exactly same as we have learned for a square root. Nth root of a multiplied by b is equals nth root of a multiply nth root of b. The radical sign is distributed to a and b both. Same happens with this property, root of a quotient, and then fractional exponent. This is same as we have learned as rational exponent. If we have radical nth root of b, we can write it as b exponent 1 upon n. If we have b exponent 1 upon n, we can write it as nth root of b. The number written in the denominator will become the index of the radical. Now the exercise. Exercise 2.6. Write down the radicand and index for the following. Radicand is the thing which is written inside the radical sign, and index is the number written outside the on the top of the radical sign. So here we have this part 1. Here 35 is the radicand and 4 is the index. Part 2, this 5 is considered as index and xyz upon t is considered as radicand. Part 3, 6 is index and 8 upon 7 is the radicand. Part 4, do it yourself. Part 5, you have to do it yourself. Now we have the question, simplify the following. Just to recall, if we have nth root of b, we can write it as b exponent 1 upon n. If we have cube root of b, we can write it as b exponent 1 upon 3. If we have fifth root of x, we can write it as x exponent 1 upon 5. Okay, now the question. Cube root of 27. We have to simplify it. So first of all, find the prime factors of 27. Prime factors of 27 will be 3 multiply 3 multiply 3. It can be written as 3 cube, and this cube root will be written as whole exponent 1 upon 3 in this way. Okay, this 3 and this 3 will be cancelled out and we will left with only 3. 3 exponent 1 is our answer. Part 7, fourth root of 625. First of all, make the prime factors of 625, then write them as power, then apply 1 upon 4 power over it and simplify it. You will get the answer. Exactly same way as you have done question number 6. Part 8, exactly same. This 8th root is written as exponent 1 upon 8. Now, whole exponent, use the law of exponent. This whole exponent will be written with a exponent 8 and b exponent 8. We have exponent over exponent. These exponents will be multiplied with each other. 8 multiplied by 1 upon 8 will be just 1. So, we will have a exponent 1 and b exponent 1 in the answer. Part 9. This symbol square root, nothing is written as an index, it means it is a square root. So the whole exponent will be 1 upon 2. We have exponent over exponent, exponents will be multiplied with each other, we will left with only 5 upon 7. In the same way, part 10 will be done. Part 11 exactly same way. Part 12, nth root of q, mth root of q. So we will write n exponent 1 upon n, sorry, nth root of q, mth root of q, we will write q exponent 1 upon n, q exponent 1 upon m. Here we can see the bases are same. So we will subtract the exponent. It will be q exponent 1 upon n minus 1 upon n. This 1 upon n minus 1 upon m will be solved together by taking the LCM. We will get m minus n upon mn. This is the answer. Part 13, you have to do it yourself in the exact same way. This 64 and 216 can be reduced, or you can find the factors. Same happens here, you can find the factors, write them as a power. Now apply the whole exponent 1 upon 3 and then solve it. Part 12, as it is, you have to do it yourself. That's it. Our exercise is done. 2.6 is done. Okay, you have to do it in your notebooks, and that's it. Thank you.